Hello and welcome to part 5 of the QED lecture on randomized controlled trials. So the previous section looked at some criticisms of RCTs and a few of the responses to those. And part of the responses is to elaborate into further designs, which we'll quickly look at now. So here's a few examples put out in the ROXO notation. So the basic example is the pre-test, post-test design. So you make sure you test before and afterwards. That's the basic elaboration. But two further ones are switching replication, otherwise known as a pipeline design. And this overcomes a couple of problems, is that even with the randomization, do you really know that you've got two completely different groups here? This group isn't somehow better than this group, or sorry, the top group isn't better than the bottom, or vice versa. So it adds to the randomization the idea that you're going to repeat the experiment the other way around. And also, of course, it overcomes that ethical problem. So the ethical problem in the first situation is that, in the top one, is that, okay, there's a group which has got this intervention which you think is beneficiary, such as mosquito nets or whatever. The bottom group are excluded. Down here, it means that they're going to get it anyway. So if you do look at any of the many examples on the JPAL website and elsewhere, you find this is used a lot. And it also overcomes the feasibility problem, because you find a government, a local government, NGO, some development project that's putting in something that they think is going to bring benefits. And all that the researchers do is they work with them so that they organise the rollout of this in a sensible way, so that you have phase 1 and phase 2. So if they randomise the order it goes out in, and then they can compare the differences in phase 1. So in phase 1, one half of the group is a control, and phase 2, the other half of the group is a control. And then Solomon 4 group, I don't know if you've been looking at this, you can work out, what's the point of this? You're kind of doing it twice. And there's, in the second group, you don't pre-test. The idea here is that when you're testing at the start, that might have an influence on people's behaviour, because people in the second set, people learn to adjust their behaviour because of the test. So having the test might influence in some way the subsequent reactions to the intervention. So here you can compare not only before and after, but with the test and without the test, to see if the levels of these groups with the 4 O's down the right hand side, if there are any significant differences there, then it might lead to you worrying that starting off with the test at the beginning had some sort of priming effect, or perhaps Hawthorne effect on the process. So other ones, well, other quasi-experimental designs are where for some reason or another you can't get that randomization. Sometimes because it's just the scale makes it impractical, sometimes it's ethical, sometimes a combination of the two, like if you're assigning people to be, you can't assign people to be in a different caste or whatever. And this is called the non-equivalent groups design. So just the same as an RCT, except there's non-random allocation. Now here, you've got to use much more sophisticated analysis, because all that stuff I showed you at the start of the lecture about how randomization magically deals with all the other factors that could be playing a role, including the unks, the unknown unknowns. There's no randomization, so you can't assume all those other known and unknown factors are the same. And they might cause the differences you see in the observations between the first and second observations. So if you see something change, maybe X had nothing to do with it. So how do you know that it's X and not something else which has caused it? So there are a number of different approaches. Two of the ones you'll hear most about is difference in differences, which is universally called diff in diff, and propensity score matching, which is a very, very popular method as well. So the diff in diff one is the simplest to understand. So for example, you're doing something X, could be education for mothers, could be a golden rice crop, could be providing food more directly, or subsidised levels of food. Does that intervention affect nutrition levels? So what you've got is a control and a treatment group that are non-randomly allocated. Maybe because you've offered, perhaps, for example, golden rice to families in an area, you can't force one family to grow golden rice, another not. So you've seen who grows it, and you want to measure the differences. So what you need to measure the control group's initial nutrition level B. So that stands for baseline. So the control group, what they start with, is the baseline. The treatment group, that's the ones that have chosen the golden rice or whatever, their initial status is defined as B plus F. So you're measuring that, whatever they measure there is B plus F. And F, you're assuming, is that difference between the groups. And F could be negative, could be they start off worse, or it could be positive if they start off better. So F is the direct effect of all the other factors until then that have meant that one group has got a different baseline level of nutrition than the other. Then the control group, who started at B, at the end of the experiment, you assume that what they end up is B plus T. So whatever they started with B and then T, and T is the change that happens without X. So T is wherever randomly is changing, those families are getting wealthier, the weather's done this, government have done that. A whole bunch of factors have changed over time, and that has affected the baseline level. And again, T could be positive or negative, depending on if things are getting better or worse. Then whatever you measure for the treatment group final level, that's going to be all these things added together. So it's the baseline plus the difference it makes because they're in that treatment group, plus the difference that happens over time anyway, plus XE. And XE is that magical thing you're looking for, which is the effect of just that intervention upon the nutrition level. And it turns out, just with simple basic A plus B arithmetic, that if you map it out like this, so this is your non-random allocation model, there's the observations. So the basic observation is 03, that's the start with the nutrition of the original group is just B. The original nutrition of the control group, of the treatment group, is B plus F. So that's F here. That's the difference between the control group and the treatment group, both here and here. So that's the same for both of them. That stays the same over time. And then you've got the effect of time, which is from here to here. That's adding on the T and adding on the T. So you've got the baseline level, which is there all the way through. You've got the F, which is the difference between the bottom row and the top row. And you've got the T, which is the difference between the left and the right. The only thing you want to single out is that bit there. And it turns out if you work out this sum, which is O2 minus O1, which is the difference in the treatment group, O4 minus O3, which is the difference in the control group, the improvement in the control group, if you just subtract those differences, you work it out, you end up just with XE. You do the calculation, do the algebra yourself if you want. This minus this means the F cancels out there. So you got, and the B cancels out. This minus this just leaves you with T. So when you subtract them, you just end up with XE. So working out that gives you exactly XE, which is very nice. And then finally, there's propensity score matching. Now, what this does is it attempts to create a control group when you haven't originally got a control group. It attempts to create one which is equivalent to the treatment group in important characteristics. And it's quite complicated to do statistically, and there's also a lot of variations in the way you can do it. But the basic logic is this: that you start off before the intervention by doing a pretest O. And here you have to gather data on anything you think could be relevant. Oops. Anything you think should be relevant, you have to gather data on. And then you use some sophisticated statistics to give the probability that an individual with any combination of those factors would be in the treatment group. Because what you're measuring is gathering data on the whole community from which that treatment group has been gathered, including the ones that have got the microcredit or the savings account or the training or the solar ovens, the ones that have got that and the ones that didn't get it. You measure the whole community of people on all possible factors, whether it's education, gender, living location, caste, whatever else I haven't said, education, smoking, taste, or whatever. All those possible factors you measure, and then you look at the group within that have got the solar ovens or the microcredits, and you say, okay, what's the probability that an individual with any combination of factors would have been chosen to have the solar oven or the microcredit or the training? So for example, suppose that in that community as a whole, there are 6 individuals who've got this combination of things. Like they're female, they're in the 40 to 45 age range, and they've only got primary education. If there's 6 people that are in that particular little box, if 2 of them have got into the treatment scheme, whatever it is, then you can assume that for that particular combination of factors, the probability of getting into the treatment group is about 2/6 or 1/3. So roughly 1/3 proportion have got into the treatment group from that category. once you've got that for every possible combination of factors, then you just look at the community, and from the community you pick out another group such that everybody in the treatment group is matched up with someone who's in the control group who's got the same scores in terms of their likelihood of getting into the treatment group. And those scores are called propensity scores. So the 1/6 that we had, was it 1/6 or 1/3? 1/3. The 1/3 above was a propensity score. And then once you've matched up each individual in the treatment group with an individual from the control group, then that gives you, or from the community, that gives you a control group. Then once you've got that group of people who've got the same propensity scores as the people in the treatment group, that control group is formed from those people, and you compare the outcomes. And you can then use diff and diff to compare the outcomes between the two groups. And a great example of this is our very own Maren Duvendak and Richard Palmer-Jones, who used to be at Dev until recently, had a very, very big intervention on the microcredits effectiveness in 2011. It does get extremely high power, the statistics in that, but that's what they wrote. That's the method they used. Okay, so in the final section of the lecture, which is reasonably short, we'll just look at how we go from designs to methods. But for now, thanks for watching.